Welcome everyone. I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1380, which is lucky numbers in a matrix. Let's see the problem description. Given an m cross n matrix of distinct numbers, return all lucky numbers in the matrix in any order. A lucky number is an element of the matrix such that it is the minimum element in its row and maximum element in its column, which means we are given a matrix and we have to find all the lucky numbers and we have to return it inside a integer array. So let's see the constant. Constant says the n and m will be less than 50 and the elements will be range from 1 to 10 to the power 5 and all elements in the matrix are distinct. So there is an algorithm, like let me clear to you the algorithm. The algorithm is like that. If you can either calculate all the minimum elements in each row or all the maximum elements in each column. So let's say we are finding the all the minimum elements in each row. Then what we can do, in we have got all the minimum elements in each row and then we will find all the maximum element in each column and we see if the maximum element is already present, like we already visited in our minimum element set or not. Okay, if it is already visited, that means we have to add it in our answer vector. Okay, and we will use a set to store all the minimum elements in the first step. So all the elements are distinct, so we can use that constant. Let's see how the algorithm works. First, we will uh, let's say int n is the matrix dot size and m is the matrix 0 dot size. So we got the n and m, which is n is the row and m is the column, and we have to create a set on order set. The data type will be int and we'll traverse the whole matrix for m equal to 0 or less than n plus plus, and we will find the minimum element in each row. So I'm creating one minimum element. Initially, let's say int max for which will equal to 0, 0 less than n, 0 plus plus. And let's say mn is equal to minimum of mn and the current element, which is matrix ij. It will give after this for loop we will get the minimal element of ith row and we have to store it. So st dot insert mn. So after this for loop, this nested for loop, we have all the minimum elements of each row. Now we will create the answer array. Vector answer, and we will find all the maximum element in each row, or sorry, in each column. So just interchange the for loops. In first we will traverse from each column. So j will be 0 to j less than m, 0 plus plus, and for each column we will traverse the whole array in row wise, and we will find the maximum element. So I'm creating a max element. Initially keep it 0 because the elements starts from 1 to 10 to the power 5. So 0 will not be present. So let's take 0 as the minimum element currently for in I equal to 0, I less than n plus plus. So it's max equal to max of max and the current element, which is matrix ij ij. So after this inner for loop, we'll get the maximum element of jth column. Okay. So let's see if it is present in our previously stored set or not. To check it, let's see, we use you can use the count, or you can just compare it like find by find or by count function, any of the two. So I'm using the count function. I just check st.count max element. If it is present, then just simply add it to our answer array. Answer that pulls back the max element. And after this nested for loop, we will have our answer. So return our answer. Let's see, we will cross now. Submit it. So you can see it is submitted. So let me discuss the time complexities and space complexities. The time complexity of this algorithm is, you can see for each row here, the inner for loop is running m times, or the number of column times. So the overall time complexity of this nested loop is m cross n, big of m cross n, where n is the number of rows and m is the number of columns. And also for this, the time complexity is big of n cross n. So overall time complexity is 2 into m cross n, or you can say big of m cross n. Okay. And space complexity, as we are storing all the minimum elements of each row, so you can say our space complexity is big of n, where n is the number of rows. Okay. So that's it for today. See you in the next video.